In this question, we're told Fred is a cricket player. When he throws a ball at the wicket from a point P, he hits it with a probability of 0.3. You may assume that successive throws are independent. Part A says in one morning he goes out to practice his throwing from the point P. Calculate the probability that he hits the wicket for the first time with his third throw. So, in order to calculate this, we're saying probability hit on the third throw is equal to, well, what's going to have to happen here? This is going to be equal to the probability of a miss and a hit. Now, since these are independent events, the way that we're going to calculate this is the probability of a miss is 0.8. 0.7. Not quite sure how 0.8 and 0.3 add up to 1. So it's 0.7 times the probability of another miss, which is 0.7, times the probability then of a hit, which is 0.3. Now, if we type this into a calculator and work this out in one go, what we should get is an answer of 0.147. Okay, so let's have a look at part B. Part B says George is also a cricket player. When he throws a ball at the wicket from the point P, he hits with probability of 0.2. You may again assume that successive throws are independent. So on another morning, Fred and George decide to play a game in which they throw balls alternately at the wicket from the point P. The winner is a player who is first to hit the wicket. Given that George throws first, find the probability that Fred wins the game with his first throw. So I'm going to use probability F1 to indicate probability Fred wins on first throw. This has got to be, in order for this to work, this is going to be the probability that George misses with the probability that Fred hits. Now, given that George misses and Fred hits is independent, probability that George misses is 0.8, and we're going to multiply that by the probability that Fred hits, which is 0.3, which is 0.24. Part 2 says find the probability that he wins with his second throw. So probability Fred wins with his second throw. Now what's going to have to happen here is we're going to have probability that George misses, and then Fred misses, and then George misses again, but that this time Fred hits. Now if you think of this in kind of like rounds, as in pairs of throws, first of all we've got George missing and Fred missing. That's going to be 0.8 times 0.7. And then you've got George missing and Fred hitting, which we already know is 0.8 times 0.3. I'm just going to simplify that a little further, and you won't know why at the moment, but it's going to help us a little bit later on. So this is going to give us 0.56 times by 0.24. I'm just going to get rid of this bracket here, because there's no real need for it. Okay, and so if I type that into my calculator and just work that out, we should get an answer of 0.1344. Now, part 3 says find a probability that Fred wins the game. Well, before we do that, I'm just going to consider the probability that Fred wins on his third throw. And this is going to help us. So for that to happen, we're going to have George misses, and Fred misses, and George misses, and Fred misses, and again George misses. So George has to miss 3 times, and then Fred has to hit on his third attempt. Now the way we can work this out is we know the probability of a round where they both miss is 0.8 times 0.7, which is 0.56. And so we're going to times that by 2 rounds, so we're going to get actually 0.56 squared, so that's going to be 2 rounds of misses, times by a round where there is a miss, which is 0.24. Okay, so let's find the probability that Fred wins the game then. Now the difficulty with probability Fred wins the game is that this game could go on forever. They could keep on throwing the balls. There is no guaranteed time that Fred will hit the wickets. So essentially this is going to be the probability of Fred wins on his first go, or Fred wins on his second go, so plus the probability Fred wins on his second go, because these are mutually exclusive events. Or he could win on his third go, so that's a probability Fred wins on his third go. Or he could win on his infinite go. Now if we have a look at this and consider this, what we've got is 0.24 plus 0.24, oops, didn't mean to do that last bracket there, times 0.56 plus 0.24 times 0.56 squared. Now hopefully at this point, plus, and it's going to go on to infinity, hopefully at this point you can recognise that this is a geometric series. We've got a first term a equals 0.24. I've got a common ratio, so I'm going from each term to term by multiplying by 0.56. And what I'm actually trying to work out here is the sum to infinity, which is a over 1 minus r. So using this information, and that's why I did the third one, because it becomes a little bit clearer hopefully to see that this is a geometric series. So using this sum to infinity now, we know that probability that Fred wins is going to be equal to a, which is 0.24, over 1 minus r, which is 0.56. And so the probability that Fred wins, if we type that into our calculator carefully and just work through it, should come out as 6 over 11. Okay then, let's have a look to see how the marks are awarded in this question then. In part A, there's a method mark for the correct calculation or attempt at a calculation, and an answer mark for getting the probability is 0.147. In part B, we have method mark for identifying it's going to be George missing and Fred hitting, and an answer mark for 0.24. In part 2, we have a method mark for identifying that it required George to miss, Fred to miss, George to miss, and Fred to hit, and an answer mark for correctly getting to the probability. And then finally, there is a method mark for identifying that this is a geometric series. There is a standalone mark for substituting the correct values for that geometric series into the sum to infinity of a geometric series. And finally, an answer mark if you've got 6/11. Okay, let's just tidy this a little bit up. Okay, well I hope you understood my solution and that you was able to follow how to mark it.